Okay, so this is chapter 4, Scale Factor Similarity, lesson 5, and this one has sound. Sorry about that, guys. So we're going to start looking at similar polygons. In the last two lessons, we looked at similar triangles, and so in this lesson, we're going to be moving to shapes with more than 3 sides. So first off, you need to know what a polygon is, so you should pause this and look up what polygon is, and then start it again so you can fill in the blank. Okay, so a polygon is any two-dimensional closed figure. So if something is two-dimensional, it's flat on the page, it's not three-dimensional. So a two-dimensional closed figure that is made of 3 or more side lengths. And those side lengths need to be straight side lengths, so straight lines. So a polygon could be anything from a square or a rectangle to a pentagon or hexagon or octagon or anything, as long as there are more than 3 straight line segments. We're talking about a regular polygon. Oh, I don't think I filled in it. Anyways, regular polygons are polygons where, like a rectangle would be a regular polygon. Non-regular polygons are like the ones on the bottom where none of the side lengths are congruent, or like no sets of parallel lines. So the lengths are all different. So we need to figure out what makes polygons similar. And on the right hand side, I have 3 different shapes, a square and 2 rectangles. And I'm actually going to make that third rectangle smaller because right now it doesn't make sense as is. So anyways, to make polygons similar, there are two things that need to be true. When we looked at triangles, only one of these things need to be true. But for polygons, they're both going to need to be true. So the first thing that needs to be true is that corresponding angles are equal. So when we look at the square or when we look at the rectangles, all of those corners are 90-degree angles. But I hope that when you look at those, you realize that none of those polygons are similar polygons, because just because they are all 90-degree angles doesn't mean that the side lengths have actually been increased or decreased by a similar scale. They're not the same shape, enlarged or reduced. They are different shapes that just all happen to have 4 90-degree corners. So in order to prove that a polygon is similar, you also need to show that the corresponding side lengths have a similar scale factor, so that corresponding side lengths are proportional. Okay, so similar corresponding side lengths are also proportional. And in order for them to be proportional, we said they need to have the same scale factors. Oh, that's Mika. He wants me to let him outside. It's too cold out. Okay, so I'm shrinking that one triangle because hopefully you notice that none of those triangles are proportional. So I'm going to try to make that one proportional to one of the other 2. So that way we can prove which ones are similar. So we're going to measure the side lengths, and when I measure them, we're going to say that the square has side lengths that are 2 units long. And so that width is also 2, and then the width of the smaller rectangle is 1, and the height of the large rectangle, let's say, is 6. So then the height of the smaller rectangle is 3. So then we need to see if any of those side lengths are proportional, so they have the same scale factor. So when we looked from A to B, we have a scale factor of the height of 3. However, when we look on the width, there's only a scale factor of 1. So A and B do not have corresponding side lengths that are proportional, so they are not similar polygons. Then when we look from B to C, we see a scale factor of 1/2, because from 2 to 1 we need to times by 1/2. And then when we check the height, we also go from 6 to 3, which is a scale factor of 1/2. So B and C are similar polygons. So on all future examples, you're going to be checking that both the angle and side lengths fit in order for the shapes to be polygons that are similar. Okay, so we have two polygons. They are quadrilaterals, meaning four-sided shapes, but they're not squares and they're not rectangles. And so we're going to check the different side lengths. So when we look at angle B and B prime, they are both 75 degrees. So they are corresponding and they are equal. When we look at A and A prime, they are corresponding angles and they are similar. R and R prime are the same angle and they are corresponding angles, and T prime. So all of the angles fit in order for these polygons to be similar. However, just having similar angles is not enough. And when you're proving if two polygons are similar, you do need to make these statements that show you've checked the angles as well as the side length. So you need to state that the corresponding angles are equal. It's not just enough to just circle them. You actually need to make that statement. So now we're going to look at corresponding side lengths, and again, using colors will be helpful. So from A to R, or green to red, so we have a length of 3 going to a length of 4.2, so it is an increase. And the way that we find that what that increase is we go 4.2 divided by 3, and so 3 times the scale factor of 1.4 gives us the new side length of 4.2. We're going to check the next side length. So 1.1, we should also be able to times that by 1.4 and get our enlarged side length, and it works. 3.5 times 1.4, that gives us 4.9, so B to T side length works. And then lastly, 1.5 times 1.4 gives us 2.1. And so all side lengths have the same scale factor. So all corresponding side lengths are proportional because they have the same scale factor of 1.4. And remember, in order for an enlargement, the scale factor needs to be greater than 1. So we would say yes, these polygons or these quadrilaterals are similar. And so that's what we need to do to prove if polygons are similar. So now we're going to look at these two shapes. These are 5-sided polygons. They are not pentagons because the 5 sides are not the same. So these are not regular polygons. So checking the angles, they both have a 90-degree angle. Those are similar. They both have a 100-degree angle. Those are similar. Sorry that the angles are so small. Okay, when we check those angles, they are similar as well, or they're the exact same. Again, we have 100-degree angle, it's similar, and then those last two angles would also be similar. So these two polygons meet the first criteria that all corresponding angles need to be equal. So you need to check that question for the side lengths and see if all angles or side lengths are proportional. Also, I would like you to try this question on your own, to draw an enlargement of the following parallelogram using a scale factor of 2. And I want you to tell me if your enlargement is similar or not. The larger angle is 135 degrees, and the smaller angles are 45 degrees. So you need to draw another polygon on some graph paper on your own, and we're going to check and see if they are actually similar or not. So the last question, you're going to check the side lengths, and this one you're going to make another parallelogram for me. We are going to do these two together. And so it says, use what you know about similar polygons to determine the missing side lengths. So when it says something like that, the question is telling you that the two shapes are similar polygons. So you need to use that fact to help you find some missing information. So from the larger to the smaller 4-sided figure, we have a reduction. And so we need to figure out what the scale factor is. or we need to figure out how much is being divided by. So we're going to set up a proportion. So we're going to set up 10.5 over 4.2 because those are the two side lengths that go together. And we're going to set up 15.8, sorry, we're going to set the two side lengths that go together on the same polygon. There we go. 10.5 goes to 4.2 on different shapes, and 10.5 and 15.8 are part of the same polygon, so they go in the same fraction. That makes more sense. So we need to figure out what the factor is. So basically we're saying these are equivalent fractions, what had to happen in order to make the fraction on the left into the fraction on the right. And so the way we can do that is we can go 10.5 divided by 4.2, and it tells us what happens. And so we will need to go 10.5 divided by 2.5, or times 1 over 2.5 to figure out the smaller lengths. So we're going to do the exact same thing on the bottom to keep these equivalent fractions. So then 15.8 will be divided by 2.5, or multiplied by 1 over 2.5, and we get a new length of 6.32. So that missing length is 6.32. On the bottom, we have on the left-hand side a small polygon, and on the right we have a larger version. So our scale factor will be greater than 1 because it's an enlargement. And so we can use any pair of corresponding sides. So you could use the two top sides on top in green, or you could use the two slanted sides on the bottom in blue, and then the two on the bottom are the ones that we're going to use to find our missing length. So 4 has to become x somehow, and if we use the two blue side lengths, 2 has to become 4.5. So we need to figure out what it needs to get multiplied by. So 4.5 divided by 2 tells us that the scale factor is 2.25. I don't know if you can hear Betty. She doesn't like what we're doing. She thinks it's really hard too, but it's not that hard. So top and bottom both get multiplied by our scale factor of 2.25, and that tells us the missing side length of x is 9 exactly. So that's it. That's the end of lesson 5.